For our final talk of the day, we have Christine Fossaceca, who will dive into one of the most interesting intersections of modern macOS security. Please welcome Christine.
All right, small but mighty crowd. Thank you. All right. So this talk is Sploit's camera action exploiting Spotlight to bypass TCC and leak data from Apple Intelligence. Actually, I'm gonna try to take this out because I'm a little short and I don't want to be hiding behind the laptop. All right. So my name is Christine. I work for Microsoft as a senior security researcher. I actually just joined the Microsoft Threat Intelligence team, so I was working on Defender for the past 3.5 years, working on the Defender for iOS app, also the macOS Defender app, as well as some other features like Copilot. So I helped ship File Analyzer, which is our automated file reversing feature in the Security Copilot portal. And I have collaborated with Microsoft Threat Intelligence as well, which is our team that tracks in the wild exploitation. So I've done some presentations with folks at Citizen Lab, Amnesty International, things like that. Unfortunately, my two co-researchers could not be here today, but I wanted to give them a shout out. So the first is Jonathan Barr-Orr, who is an incredible researcher in his own right. I like to say that everything JBO touches turns to CVE because he's just so knowledgeable about a variety of different platforms. So definitely check out his website to see his full list of things that he's exploited. And then also Alexia Wilson is another incredible security researcher and also developer. So Alexia has actually spent time on the Defender engine team writing the code in macOS. So yeah, shout out to them. They're really awesome to work with. Also, if anybody here went to Yonsei University, I actually studied abroad there, so shout out Yonsei University. All right, so today I'm going to tell you about our Spotlight exploit, but in order to understand that at a deeper level, you need to understand TCC and entitlements. Then I'll dig into the Spotlight service itself and some of the past exploits that we've seen for Spotlight. Then I'll give you an explanation of the exploit and, of course, a demo of Sploit 1. And then I want to talk about some of the sensitive data leak implications because TCC, any bypass of TCC is a sensitive data leak. And I'm going to talk about Apple Intelligence and some of the sensitive data that can be leaked there. Then I'm really excited because we've never been able to talk about Sploit 2, but Apple just patched it last week, so this is like a really great last-minute add to this talk. And then some takeaways. All right, so first, what is TCC? TCC stands for Transparency, Consent, and Control. And so this is a privileged mechanism that Apple has added into operating systems in order to govern access to sensitive information. So some of that sensitive information is just things like your files, like the desktop folder, downloads folder, microphone, camera, location information, iCloud information, screen recording, things like that. And so all of these different elements that TCC is protecting is governed by a TCC service type. And so I'll talk about that a little bit more when I get into entitlements. So you probably have seen TCC even if you didn't know what it is. So this would be in your settings. If you see like full disk access pop up with that like toggleable button, this is where TCC it lives, and this is how you can modify it. Also, you might get this pop-up from something asking to give like full disk access to terminal or another app, and so this is another way that TCC is represented. However, you cannot control TCC any other way because it's actually controlled by the TCCD daemon. So all of the services are stored in a like preferences database called TCCDB, and then the TCCD daemon is what edits that database. So there's a per user TCCDB as well as a system-wide TCCDB that stores those preferences. And so the per user TCCDB requires full disk access to read or write to it. The system-wide TCC DB is a little bit more protected. It requires full disk access to read it, but then it's also SIP protected. SIP is another Apple security mechanism. So even if you have root, you should not be able to write to the system-wide TCC DB. So basically, a TCC bypass is just when you're able to access some type of sensitive data that is supposed to be TCC protected, and you're just like not getting this pop-up, and that information is displayed to you in some way. So I actually came from an iOS exploit dev background when I came to Microsoft, and I wasn't familiar with Mac OS exploitation. And JBO brought me and Alexia into this space. And so he taught us that there's like 2 different kinds of TCC bypasses. And I really liked the way that he explained it. So now when I explain it to other people, I follow his model. There's partial TCC bypasses and complete TCC bypasses. And so this will make more sense when I talk about the entitlements. But basically, a complete TCC bypass means that you have arbitrary access to TCC services. So that would be something like modifying the TCC DB, because you can have access to like everything. So this would be like the location information, full disk information, microphone, camera, etc. Whereas a partial TCC bypass would be you're only having access to one or like maybe a few system services. So maybe you're exploiting some specific app, but you only got access to like the microphone or something. So to put that into like something concrete to make it a little bit easier to understand, I wanted to give some examples. So in 2022, we reported the PowerDir vulnerability, which was just able to plant a fake TCCDB. So this is arbitrary access and modifying TCCDB because we were able to fully change that database. So that's considered a full TCC bypass, because if you give yourself access to all of the TCC services or an arbitrary app access to all of those TCC services, that's just everything you would need to fully bypass TCC in every way. In 2025, earlier this year, we also reported HMSurf, which was just a Safari TCC bypass. And because Safari doesn't have access to all those services, it only has access to like browsing history, the camera, and the microphone, even though we were able to make some modifications to the per site database that is TCC protected within Safari, we weren't able to add any additional TCC services, so it's still only a partial bypass. All right, so now what are entitlements? So entitlements are a security mechanism designed by Apple, and it's supposed to protect specific features or permission to leverage specific features or services in the operating system, like iOS or macOS. So these are supposed to be tightly coupled with digital signatures, and so entitlements are usually applied to specific binaries. And if you modify those entitlements in some way, it's supposed to invalidate the signature. Now, we've seen in practice over the years that it's not always implemented like this, and that's not always the case. And early iOS and macOS exploitation was literally just like stealing entitlements and applying it to your binary and then getting access to things that entitlement protected. So by trying to couple it with the digital signature, that's supposed to provide protection, but implementation is really a huge part of it, and sometimes things aren't always implemented correctly. But if it was implemented in a perfect world the way it was supposed to be, then you'd be able to leverage it the way it's supposed to. So there's public and private entitlements. So as an example, third-party developers, if they want to access certain things or have certain features in their app, they need to have the entitlement that accesses that feature. So like if you want to have network connections in your app, you need to use Apple Security Network Client so that you can have outbound network connections. If you want to like select files, you need to have this security files user read write and apply that. And so third-party developers are normally allowed to just use like whatever public entitlements they want. There are certain entitlements that need to be assigned to you specifically by Apple. So kind of a middle ground of like not necessarily a private entitlement, but would be a partner entitlement. So Microsoft has a product called Defender, and Defender is an endpoint security product. Any company that has an endpoint security product needs to use the endpoint security framework entitlement, and that entitlement is actually issued per vendor, so each vendor has their own endpoint security entitlement. There's also private entitlements, and so these are supposed to only be used by like internal processes, internal Apple processes, and Apple itself. We also know that that's not always the case. However, some of the common ones that we see in exploitation are COM Apple system task ports, because getting task ports is very important. And then COM Apple private TCC allow. So this entitlement is what lists all of the services, and it's the entitlement that allows you to bypass TCC, because having this entitlement means that TCC will not be checked for those services. So like I mentioned, with the way that Apple has added mitigations over time, made entitlements a little bit more secure, things like that. Now exploitation is going to focus on bypassing binaries that have these TCC specific entitlements already. So you can't just like steal this entitlement and apply it to your binary. You're going to focus on a binary that already has either COM Apple private TCC allow or COM Apple private TCC manager. And just to mention, I will talk about how this is applied to Spotlight when I talk about the MD worker and MD worker shared binaries. So to make this more concrete, I'll talk about Safari, because Safari has these TCC bypassing entitlements. And so it's a little hard to see, so I'm going to just zoom in here. And so you can see that these are all those TCC services that are listed. So it's COM Apple TCC allow, and then each individual service that is provided to that binary is enumerated below. So Safari has access to the address book, the camera, microphone, screen capture, calendar, all of these different things. So this isn't like all of TCC, but if you are able to bypass TCC in Safari, it's a partial TCC exploit because you're only getting access to these specific services. You're not adding any additional services. So in exploitation, there's a lot of different attractive entitled targets, and you'll look for those targets because those targets will have access to the things that you want to do. So this is just an example of a bunch of different bypasses that have happened. Both SIP bypasses require specific entitlements and TCC bypasses. And so this talk is called Sploit because we have a TCC bypass in Spotlight. All right, so you might be wondering, like, what is Spotlight? And so that's an indexing service on Mac OS. Most people probably don't use it from the command line, but there is a command line utility called mdfind. And so basically it's supposed to index based on file names and file contents and make it easier to search for files on your machine. Anybody that has a Mac has probably done like spacebar, and they're able to search for files on their machine. And so you can, that is what Spotlight is doing. That's only enabled because Spotlight has been indexing all of the files on your machine in the background. So you can see here, when you type in POC, it looks across the internet for things that are maybe related to what you're searching. It's also trying to do some predictive enumeration of what you might be saying. So maybe it thinks that you started typing a word that you want to search on the internet. And then below, when you look at the documents, that's actually the files that have been indexed by Spotlight. So the first 3 files that are listed are files that have POC in the title, but we wanted to prove that Spotlight is not just indexing based on file name, it's actually also indexing based on file contents. So highlighting this file below, you can see that it doesn't have POC in the title, but it's still popping up, and that's because Spotlight has indexed the contents of that file. And Spotlight has been exploited probably for like at least the past 10 years. I was able to find CVEs going back to 2014. Patrick Wardle talked about it at Black Hat in 2015. And it's just a really attack-rich surface. Like there's probably people at this conference that have exploited Spotlight in some way, not always with a TCC bypass per se, but like it's just an attack-rich surface. So I wanted to highlight this because it really has been very commonly targeted, and I think part of it is due to the way that it's architected is just not very secure, so it kind of lends itself to an attack-rich surface. So like most Apple services, it's pretty complex, and there's usually multiple binaries that are part of like the orchestration of what's going on. So the first binary is MDS, and this is kind of like the launcher, because this binary is what's launching MD Worker shared in a sandbox so that they can operate. MD Worker and MD Worker shared are actually the binaries that are doing the indexing on your machine. And then those indexed files are stored in Spotlight v100 files. And so those files themselves are TCC protected. So full disk access needs to be granted in order to access those. And then there's another binary, core Spotlight D. You can also interact with Spotlight with different command line utilities. So I mentioned mdfind, but there's also mdutil and mdimport, which we'll talk about later. But basically, when it comes to Spotlight, there's all of these different binaries, and when we first sought out to try and exploit this, we had to figure out which binaries were the ones that like actually were indexing the information and which ones were doing things and which ones you're supposed to target for exploitation. So we didn't really research the Spotlight v100 files, but I thought it might be interesting to just show you what that directory looks like. And the reason why we didn't target this for exploitation is because even though we know that these Spotlight files are storing some kind of like version of your data in a cached way, and so it could be really interesting, could have a lot of sensitive information. It's already protected by TCC, so we were looking for a TCC bypass in Spotlight. So we just didn't look into this, but I think that this could be a really interesting area of future research. But it's also its own data format, so you would have to kind of like analyze that. So Spotlight needs to know how to index contents from arbitrary file types. And so because of this, it's actually split into a bunch of different plugins. So if you look in the systems directory, you can see how Apple has defined plugins for different file types. So you can see there's like an application parser called application.mdimporter, an archives parser called archives.mdimporter, audio MD importer, and so for like every file type that's like an Apple known file type that Apple thinks would be necessary to parse, there's going to be this MD importer file, and that is considered a Spotlight plugin or Spotlight parser. And so maybe you're thinking from like an exploit standpoint, oh, well, I can just like modify one of these and that's a way to exploit, but you would need like a SIP bypass or something to be able to modify that because a system's not supposed to be able to be tampered with. All right, so like I mentioned, MD Worker shared is indexing these files, and these files are usually sensitive information because it's things like from your documents folder or maybe photos or something like that. So anything that is sensitive information is supposed to be protected by TCC, meaning that that binary is going to have TCC bypassing entitlements. So we know that MD Worker shared has KTCC service system policy all files, which is essentially the TCC service for full disk access. There's also a few other services, so I'll show you all of the TCC services that are enumerated in MD Worker. So you'll see like there's address book, calendar, and reminders as well. And so MD Worker shared is supposed to be sandboxed. So I mentioned before, this is enforced by MDS because MDS is going to launch MD Worker and launch MD Worker shared. MDS is supposed to pass the files that are supposed to be read via XPC. And so you're supposed to be really limited as a Spotlight plugin because you're not supposed to have any network access. You're not supposed to be able to fork anything. So a lot of like typical exploitation techniques where you're like injecting into a binary and forking so that you inherit all of those entitlements, like that's not supposed to work here. You can't like leak data externally because you don't have network access. Really all you can do is read files. And so it doesn't seem like you really can do much. And so before I jump in, I did want to share, like, if you know anything about the sandbox, you can look at everything that MD Worker can do, or rather, what MD Worker can't do by looking at the sandbox profile. So there's a lot of like interesting information in here. Also, if you're interested in like looking at other sandbox extensions or sandbox profiles, you can look at a binary and look at this sandbox extension issue file to self. And so this is like going to give you information about what it can or can't do. So this is where the binary is essentially saying like, put myself in jail before I do anything. So now looking at the entitlements of MD Worker shared itself, I did want to highlight here. So flags none, if there's flags set, those flags would allude to like some type of system protection or binary protection. So like hardened runtime would mean that a flag set. So flags none means that like nothing special protection-wise is being added to this binary. So yes, it's sandboxed, but there's like no hardened runtime or anything like that. And then as promised, apple private TCC allow enumerates those TCC services, but you see that we're pretty limited. So we do get K TCC service, system policy, all files, which even though it's just one TCC service, it is actually a pretty powerful one because that's full disk access. So that means that like they could access any file. So full disk access is a pretty important entitlement. And then there's like address book, calendar, and reminders. Okay, so this is still, even though like full disk access is an important entitlement, it's still considered a partial bypass because it's not like arbitrary entitlements. So I mentioned that Apple has defined various plugins for different data types that are in the system folder. However, you can actually write your own plugins, and it's really, really easy, and there's like no protections around it. And we think that Apple did this because even though there's data types that are like known and that Apple has said you have to be able to process, they also want to support vendors in their ecosystem. So as an example, Apple doesn't want to write a Spotlight plugin to parse docx files because they don't make Microsoft Word. They would rather allow for like Microsoft to write a plugin to parse docx files. But anybody can write a plugin, and it doesn't need to be signed, and you don't need to like run it with root access. So anybody can just write a plugin and put it in the home library Spotlight folder. It's going to be an MD importer bundle file. And then Spotlight automatically runs these in the background by itself. So like eventually it will just run your indexer that you've planted on the machine. So I do want to shout out Chaba Fitzel because we used his code as like our framework for trying to understand how Spotlight importers work and how to write our own plugin. So this is his repo because he actually used Spotlight plugins as a persistence mechanism in one of his previous exploits. So again, like I said, Spotlight has been exploited so many times. It's really an attack-rich surface. And so it's really simple. Spotlight plugins are data parsers. So you just have to say what data or what data type you're parsing and then how to parse that data or what you want it to do with that data. So you have to define like two different things related to the data types. You have to define the info.plist, which has some of the uniform type identifiers of the data types, and I'll talk about those. And then you need another metadata file, schema XML, which basically has the same information. And then you have to implement a method, get metadata for file, which basically says what to do with the data. And so I'll talk about those. And so what we found with this is that sandboxing is not sufficient because you're really only supposed to be able to read the data, which doesn't sound like much, but when you can read data from somewhere, what you have to be careful of is if that data can be leaked somewhere else. So just because something is read-only access doesn't mean that it's like unexploitable. And so sandboxing MD Worker is not sufficient. And so you can leak data that is readable in many, many, many different ways. We chose the standard log the first time. And so this is basically like the main part of the exploit. And it's a little silly like how easy this was. It could have been done by like ChatGPT. So first, all you're doing is you're pointing to the file that you want to read, and you're getting the file size. And the original version, like V1 of this exploit, was us just pointing to a very, very tiny file and then leaking it to the log. And then we were like, okay, now that we know that we can read data to the log, we want to read like larger data to the log. So we were like, okay, let's point this to a picture file. And then suddenly the exploit wasn't working anymore and it wasn't reading anything to the log. And we realized that the console actually like truncates data at 40 bytes. So you have to manually chunk it yourself. But if you look at this code, like we're not doing anything besides reading. And then we're like writing to the log, but not really because the log is just reading. So that's the get metadata for file function that I mentioned, but there's two things that we're missing here. We have to be able to trigger the exploit because we don't want to wait for Spotlight to like trigger our plugin. We want to be able to trigger it arbitrarily. We needed to be able to trigger it immediately and iteratively as we were developing the exploit. And then we also had to expand it for different UTIs, different uniform types. And so the triggering part was pretty easy. I talked about how you can interact with different command line utilities with Spotlight. And so in order to force Spotlight to load your plugin, you're going to invoke MD import I. And so it literally, if you like read the man page for it, it says it's used to test Spotlight plugins, list installed plugins. So if you're like iterating on this and you want to play with this, instead of sitting around waiting for the operating system to load your Spotlight plugin, you can just force it with MD import. So the next part is discovering arbitrary UTIs, because with the POC that we started with that framework of another Spotlight plugin, that was only for one type of file, and we were like, okay, we want to read arbitrary files because we're looking at leaking the absolute most data and trying to figure out how to make this TCC bypass like the most impactful. So we had to modify that info.plist and that schema file, and that means that we had to understand what UTIs were. So on the command line, if you use UT type or MDLS on a Mac computer on a specific file, that will inform you as to what the UTI is for a specific type of file. So it's basically just like the data type assigned to that type of file. So like regular common files, like JPEGs or PNGs or text files all have these like public UTIs. But then vendors are also able to define their own UTIs. So like COM Adobe PDF. So Adobe has defined a UTI for PDFs. Microsoft has defined a UTI for docx files. And then the last thing that we saw that was interesting as we were like testing different files was that there was this weird one that had like a DYN. And so that's a dynamic type. And so dynamic types are for like files that haven't been defined by either like being a regular file or it hasn't been defined by a specific vendor. That will just be assigned this like dynamic type. So if you are interested in recreating this yourself, you can look at different UTIs using that MTS utility, and you can see that it's basically like a content tree that you walk up the tree. And so public PNG is defined by these other UTIs. So it's fairly simple. And something that was interesting, so what we noticed when we were developing this was that that DYN with the like large number attached that looked like a hash, we couldn't really tell what that was and how it was generated, but we noticed that it was changing between machines. And so if like somebody who had an exploit wanted to pivot across machines to leak arbitrary type data, it wouldn't work going from one machine to another because you would have to figure out what that arbitrary type was. But with the way that Spotlight is designed, that's like not super complicated to do because the plugin's not signed. You don't have to like even recompile it when you make changes because when you're making changes to like info.plist and schema XML, like that doesn't require a recompilation. So yeah, it's pretty easy for somebody to take advantage of that if they had wanted to. So in the final version of the exploit, we showed that you should not have access to a TCC protected file. So we looked at photos. And so the photos library folder is supposed to be TCC protected. And if you ls it, like you'll see operation not permitted. And so then we're able to completely bypass it with this. So I'll show you, and I'll kind of talk through what it's doing as the video plays. And I'm going to zoom in a little bit. So you can see we did ls, and it's not permitted, and so we're going to run the exploit against it. And what the exploit does is it literally just takes that small code, it copies it to the home directory for Spotlight importers, and then it calls MDI import on our plugin to force the plugin to run. And then we point the plugin to that directory, and then it indexes it. And so as it's indexing all of those photos, it starts leaking it to the console. So anytime you're able to read arbitrary files, that's a TCC bypass. So it's pretty simple. And so if you were malicious, you would potentially be able to read all different files across a machine because you can like guess the file types in a folder and just run MD import on all of those directories recursively. So you can like slice and dice by specific file types if you can determine the UTIs for all of those file types, or you can just use the dynamic type. And so we started thinking about what are like some super interesting files we can read, you know, private documents, proprietary documents, even seeing like TCC databases, like that's really interesting. But then we started thinking about Apple Intelligence. So Apple Intelligence is like the personal AI assistant that Apple created in order to make our lives easier. So it has cool features like it has assistive writing on mail and notes. It also will do like smartphone replies and summaries. It also does notification summaries. So like let's say you lock your computer and you walk away and you come back, all of your notifications will be summarized for you so you can kind of like get through them a little faster. It also enhances photo search so that you can look through photos in natural language, but there's also like a really interesting metadata enhancement that happens that I'll show you. It also does audio transcription. So when you think about like generative AI and all of these different things that we're using AI for, you think like, oh yeah, it's adding a lot of convenience. But what it's also doing is it's adding a lot of data, because a lot of this data that it's generating is going to be stored somewhere else on your machine. So now it's either duplicating existing data or it's creating a summary of existing data. So the design of this means that it's going to require caching because it's generating all of this metadata. So, for example, photo tagging is something that's cached, and so this enriched photo tagging is something that's going to be cached on your machine. So the earlier directory that we were able to leak was photos libraries and then like photos.photos library. But the Apple Intelligence version of that is this syndication photos library database. And so this is specifically an Apple Intelligence photos library database. And so we were looking through this trying to understand like what was important and what was not because there are just so many different files. But we found that photos.sqlite was like the most important. So to give an example of some of this like enriched photo tagging that happens, previously what Apple would do was it would just do kind of like basic facial tagging. So it would tag me and it would know my face, and then it would tag my dog as like a dog. But now with Apple Intelligence, there's actually enriched metadata. So it actually can tell with accuracy what type of breed my dog is. So it's just kind of crazy that it's able to do that because that is just so much more than what it could do in the past. And so it got us thinking about, okay, if it's enriching data without us asking to that extent, what is it doing when you take pictures of something maybe more sensitive? For example, if you travel a lot, maybe you have a picture of your passport, maybe you took a picture of your credit card for some reason. So when we think about some of this intelligence information, when this data is being enriched, it's also adding knowledge and almost making it easier to index your files. So like previously, if an attacker was going to target your machine, they would basically have to either spend time looking through the data themselves or like exfil a lot of data on their own before they necessarily find something useful. But with Apple Intelligence and this enriched metadata, it actually makes it easier for them to target these files because now everything is just like summarized for them really easily. So Photos SQLite seem to have like some of the juiciest information just like stored right there, really easy. So instead of having to like look at every single picture, you can just get it in this other place now instead. So there's geolocation data. Again, that photo and video metadata, but it's that enriched metadata, recognition information, user activity and event context, search history, deleted photos, things like that. So when you think about like the privacy implications of this, that's a lot of information. But then that's also synchronized between devices based on your iCloud account. So if you've ever like logged into your work computer with your personal iCloud account, which you should not do, now suddenly everything is being cross-contaminated. So that means that Apple Intelligence on your work computer is now indexing all of your personal files, and all of your personal Apple Intelligence Assistant is now indexing your work files. So just like something to think about. So digging into the implications, especially when it comes to like agentic solutions, because not only are we, adding enriched metadata to all of our files, but now we're using these agentic solutions, and now they're maybe parsing all of our files. So this is all of the information that we're giving these solutions access to. So latitude, longitudinal data, and so we'll actually see this twice. We see this here, and then we'll also see it in weather. But lat long information, especially like in the Apple ecosystem, is very, very accurate. They give like, we had to redact it because it basically was like showing somebody's house. So that is, a privacy consideration. Also, something to think about, especially when it comes to the data that it's creating. So if you have some type of agentic solution or even like Spotlight indexing or something like that, sometimes data that is supposed to be encrypted or protected in some kind of way is no longer going to be. So when you look at like iMessage, for example, iMessages are supposed to be encrypted. However, if you have, some other agent that is reading your messages and then summarizing them for you, even if those summaries are TCC protected, if you have a TCC bypass, now suddenly they're able to access the contents of your message. So there's just a lot of like implications that people don't think about. Also, like if you're browsing the internet, remember those URLs are going to be stored in Safari, which is going to be indexed by Apple Intelligence. Also with mail, just like another example. So either if you have like a very short email, the entire contents of the email will be included in the summary because it's too short to summarize. Or for an attacker, instead of having to like exfil all of your email, they'll just be able to focus on the summaries of the like most important proprietary emails. So just like another implication to think about because this can be pretty serious. And then again with weather, so I think a lot of people don't realize that like weather information is pretty sensitive. In order to like write an iOS app that even uses the weather, you actually need to use like a weather kit entitlement, and it's because weather information is using your very, very accurate location, your very, very accurate latitude and longitude to tell you where the weather is. So weather is kind of like locked down because of that location access. So not only do we have to make sure that we're making sure our pictures aren't leaking our information, but also like weather can leak our information. And the last thing that you have to think about, especially when like either having a TCC bypass that can, directly access this, or maybe you're leveraging some type of like AI agent that's supposed to be summarizing things for you, is this knowledge CDB. And I feel like a lot of people should know about this, but knowledge CDB is almost like an events database of what happens on your machine. So this is like, opening and closing apps, and just like kind of everything that happens on your computer is in this knowledge CDB. And so yes, that's probably so useful for your AI assistant to know everything that you're doing on your machine, but it also can be exploited. And so like, why am I like going on this rant talking about all of this sensitive data? Well, all of the sensitive data is supposed to be protected by TCC. So when you have a TCC bypass, you can suddenly access all of the sensitive data that is supposed to be protected, and that can be a little scary. And the other thing to think about is like for end users, is like this pop-up enough for them to know what they're allowing? And I don't think it is, especially when you think about these agentic solutions that we're giving access to things. Like again, if you just say allow, like now you're granting that TCC access. So you're saying to, like, let's say you download some third-party app because you want to make a really cool avatar of yourself for your profile using AI. You're saying, yeah, have full access, like full disk access, and then suddenly they have access to all of your photos, which you didn't know had all of this enriched metadata about the breed of your dog and where your house is and like all of this stuff. So just be careful when giving access to things, because maybe you just wanted to give them like 3 pictures of you to make a cool avatar and not also like know where you live. Okay, so now talking about the fix to Sploit Lite 1. So even though it was a Spotlight exploit, Apple patched it under logging. And we were a little confused because we were like, first of all, this is a Spotlight exploit, so why was logging patched? And then also, why was this patched for like all of Apple's operating systems? So like we only gave them the POC for a Mac Spotlight plugin, but iOS, iPadOS, visionOS, and macOS were like all impacted, and we were like, what the heck? Like I thought I stopped doing iOS exploit dev, and then like somehow I still had an iOS CVE. So that was kind of funny. And so that made us think about it, because we were like, is this fixed? So we weren't really sure, so we dug in. And so like in like the early exploit testing stages before we had the fancy POC, we would literally just like grep the log for our exploit. And so we were like, okay, like they patched the log, so it's not writing to the log anymore, but like, is it actually fixed? And so this actually, full credit for Sploit 2, it goes to JBO, because he had this like crazy idea, because we felt like it wasn't patched, but we were like, even though you get that feeling it's not patched, but like POC or GTFO, right? So he like kind of kept ruminating on it, and he was like, well, like other things can write to the log, just the plugin can't write to the log, but other things should be able to. And network connections are not allowed, but if a network connection fails, will something still write to the log, like the sandbox? And so what he found was that port numbers of failed connections are written to the log. So this was like a kind of a silly thing, because it's almost like a covert channel, because you literally are leaking like byte by byte, but hey, like a leak is a leak, no matter how small. So if you go back to like the get metadata for file function and you modify it, instead of doing what we did where we wrote byte by byte to the log, we're now calling this open socket function on each byte. And then to make sure that it was actually like logged, because we didn't want to have an invalid port, because like that's a different error. We had to make sure it was like just a real port. So we added 1,000 to the byte. But literally like it would just log that to the console. So it was not like as a one-liner like our other one was, but you could literally leak an entire file byte by byte with that. And so that was actually a second exploit. So that was Sploit 2.0. And so what was interesting was that other people also, like an anonymous researcher and like somebody else, also had something similar. So I don't know like if it was, I don't think for other people it was related to the TCC bypass. So we like chained this with the TCC bypass, but other people noticed this as well. And so that kind of goes to like just the Spotlight architecture. So I wanted to highlight this. So Apple recently announced that they're changing their security bounty, and they're trying to like reward researchers more for different types of exploits. And they specifically called out TCC bypasses. So I thought that was really, really awesome. Because to be honest, like their TCC bypasses are not that complicated of exploits. Like I think that there's a lot of them. Like there's so many, and they're pretty easy to find, especially because as long as you're targeting like those TCC bypassing binaries, you should be able to find one. And just like as an example, so sometimes like the payout prior to this announcement was like pretty inconsistent. Like for Sploit 1, they gave us 30K, and for Sploit 2, they were just like, eh. So I don't know if they were like other people found it too, so like you're not special or what. But they're kind of going back now and making a promise that they are going to prioritize it even more, even though they're so common. So I think that's pretty great. And so I wanted to leave you guys with like something you can do, because I keep saying, you know, Spotlight is this attack-rich surface, and I think that with everything that we saw today, like Spotlight does have so many different things going on for it. And when you think about like, okay, this time they patched Spotlight, but is it fully patched? To be seen. And that may be alluding to something else coming down the road. But if you are interested in maybe finding other iterations of this exploit, I wanted to thank Blacktop, because he actually uploaded a diff for me of macOS 15.3.2 and 15.4, it was pretty big to diff, because they're just like really large files. So if you're interested in seeing the logging patch, I think that would be really good to look at. And then also iOS and iPadOS. So we've not explored like what changed in those operating systems related to this patch. So I think that that also could be really, really interesting. So I hate to keep like making the same point over and over again, but with the rise of AI, I feel like we really need to be careful about what data is being shared with agents, what data is being generated by agents, and then how that data is being protected. And so as we've kind of proven here, like TCC is not sufficient to protect that data because it is so easily bypassable. And Spotlight in particular, like there's design issues there, and there's kind of a lack of digital signature enforcement and just a lot of different things that I think need to be changed to really like move the needle on Spotlight security. But one of the problems here is that variant analysis is tough because there are just like so many different ways to not only exploit Spotlight, but also just like understand like all of these different elements of TCC. So that's how like we've been able to continually re-exploit this after a patch because there's just like so many different things that you can do. So yeah, I just think that all in all, like I'm really happy that we have this community of people because everybody's really excited about trying to find what the next bug is and then reporting it to Apple and trying to get them to fix it. So I think the more people focusing on this will make them take Spotlight a little more seriously. So yeah, thank you so much.